Okay, let's go. There's quite a few interesting things going on in Clapland at the moment, in the background, kind of, which you will probably hear more about quite soon. But that made me think a little bit, and I decided to be a little bit more outspoken, or maybe promoting, maybe not promoting, but telling more people about my toolkit, which I think is getting in such a state that this could be useful for other people, except me too. But I am not very good in this presentation or promotion thing at all. It feels extremely uncomfortable, not. I don't like it that much anyway. But I decide just jump into it and see what happens. It will turn out like crap probably, but who cares? Who cares? Let's see. So instead of going to this typical presentation thing, what is it, who made it, who am I, and that kind of crap, I decided to just jump into it and just compile one of the plugins I have been working on, or more example plugins or test plugins you can say. But I plan to kind of improve it until it becomes more like a proper plugin. But at the moment it's more like a test plugin to test features and stuff. It's an instrument synthesizer with some interesting clap features, but let's compile it, and I can show it to you first. And first I compile a clap version. Let's see, and it will here it dumped down in my directory, and I can start it in it's easy as a Bitwig, so I use Bitwig also to show the modulation stuff. So the plugin itself, let's see here. I think it's gigantic size, 2.5 megabyte. It's like a mammoth, a behemoth, but I can get it down to 200-300K, or even less if I disable the GUI. But anyway, this is the debug test, so no early access, please. I instructed Bitwig again to look into this directory for plugins, and so it automatically pops up when you compile it, and there you see it with a nice little clap symbol on it and everything. And now you can just drag it into BAV, and here it is. It's not a very massive plugin, it's quite limited and maybe primitive and naive, but it works as a testing, and so let's see. It has 2 oscillators and a mix or combination way, and a filter and an envelope. So you can also play it. It has a bunch of the nice clap goodies like monophonic and polyphonic modulation, voice stacking. It supports the thread pool extension, so it calculates voices multi-threaded. It has remote controls, parameter indication. It has a resizable GPU accelerated GUI, smoothly resizable. And the parameter stuff and modulating stuff is happening automatically in the background, so you don't really have to think about it. You just create a parameter and you create a widget, and then you connect them and forget about it, which is quite nice to automatically. But let's try a few of the features. The synth itself is, as I said, it's not very interesting. If you can change some of the typical triangle, save, square wave pulse and stuff, and you have some tuning. Then you can mix the 2 voices in separate in specific ways, for example, like modulate things a bit, like phase modulation. There is no de-zipping or anything like that at the moment either, because I'm still thinking about it, how to do it properly. And then finally it has a filter, simple filter. Of course it works more for. And then finally it has an envelope, simple. Oh, it's ugly. This low pass stuff is crap. Okay, let's just mix them. Let's make it very simple here to hear what's going on. So it is a pure, almost pure sine waves. And let's see, so that's the synth part. As I mentioned, we have, let me have to control the comp. It has this remote controls, which is, let's see, this part that automatically, that's typical 8 knobs on the MIDI controllers. You can make them automatically map to some knobs on your, oh, there's something wrong with my controller. Map them automatically to some parameters on your GUI, so you can just select the track and then start tweaking, which is really nice. I like that a lot. And it has, together with these remote controls, it also has this parameter indication, which is this colored stuff, triangles on the top corner here. So if you see, if I select another track, they disappear, because now these controls are not mapped to the MIDI controller. And when I go back, it's automatically mapping. And they also show or indicate, let's say this, automation. So you can, for example, as soon as, for example, this frequency, if we, for example, let's say just add in a bam, envelope pointer, you see, oh, bang, that pops up this blue circle here, which means there are automation for this parameter. We can delete it again, bang, I did this, oh, sorry, delete. No, why doesn't it want to go away? Delete it. Then it turns gray, which means there is an automation lane, but no automation in it. So kind of disable everything. But of course, if you have automation, it will automate, of course. Oh, sorry. I pressed the wrong buttons here. So if we just play a little bit here now, you see this automated automatically. Use, of course, typical. That's not very special in plugins, of course. But if you turn it manually, it turns green, which means overridden, which means now you are manually set it to something different, which means it turns green the same as this. And then if you click this green button, it goes back to blue. And of course, if you have a record enabled, it turns red as soon as you start recording. So it indicates the state quite nicely about what you are actually doing, what is happening with the control when you see things going up and down and all that kind of stuff, which is, I think, is really nice. I like it. And it's automatically happening with all this. What else? We can do voice stack. Let's say, okay, modulation is interesting. Let's say if I want to modulate this one instead. Let's get rid of this on the automation lane. Wow, get it. Wow, of course I have to do this and then delete. Where is it? There's good. There's gone. It's gone. And with a modulation, that is interesting, because as you saw, that automation is actually turning the parameter for you. But which means you lose the original setting where it actually is, for example. But you can, additional to automation, you can have a modulation on top of it. So if you have this value of the parameter, you can have a modulated parameter on top of it, kind of, in addition, which looks like this. Let's see if I want to modulate this one now. A little more. This one, for example. Then I just add an, it's easy in Bitwig, of course, but I expect more hosts to start adding modulation stuff in later, when people discover how nice modulation actually is. So what we can do now is actually modulate this same parameter. Frequency here, frequency here. In addition, as you can see, and then turn it off, and you can see it is addition to the value. So it goes kind of around the value. But this first, this version here is monophonic, because it's all the. So you could just as well have a effect plugin after the synth, actually, even if you no matter what you're playing. But the interesting part is when you click on this polyphonic. Nowadays there is a LFO or a modulator per voice. So if you you hear them go manually, which is really interesting. And still, you can still, or even you can even automate it additionally. Like let's see if we can find it. And in addition, we can also let's say let it go a little bit like this, for example, for testing. So we could have play it, of course, and you can see it, but the modulation still goes around the automated value. Which is really nice. And a third thing you could add on top of that is voice stacking. Now, every time I press a key, there's one key, of course, and if I press another key, yeah, the typical 2 keys. But you can play the same key multiple times. Hard to do in a traditional MIDI keyboard unless you have a long release rate. As you can see here, you see the number of dots. You see 1, 2, 3, you see multiple dots. All these are playing the same note now, but you don't hear it much. But what you can do is switch on voice stacking. Let's try 5 now. You could go to 16, but let's try 5, which means that for every time I play at this middle C, Bitwig or the host will send 5 middle Cs or the same key to the plugin. So you see it right, let it stop here. Why doesn't it stop? If I hold on, you see the 5 dots here now, all of a sudden. And the volume scores 5 times louder, because they're all playing the same frequency and volume and everything. But the interesting thing with voice stacking is that you can spread out a little bit different settings for a bunch of parameters for every voice. So, for example, what we can do is just change this, for example, this tuning here. So if every voice gets a little bit different tuning, you get this nice kind of super saw thing. Like this. Let's say we want to, where is it? It is the cent value here, which is the cent. Where is it? Yes, it is the right one. Yes, cent. And now we can to modulate this cent value a little bit, which means that every note now get a little bit different settings for this cent value, so it kind of modulates it a little bit. So of course it uses a lot more CPU because it's playing 5 voices for every 5, and I can actually drag it up to 16. So now it's actually playing 16 voices for the same voice, and they are all modulated and they are automated. And it's still, as you can see, interesting. There's one interesting thing with the clap actually. I don't think you can do that in VC3 or anything. Let's say a long release. You hear the modulation going on. You can do a lot, probably do a lot of that with note expressions in other plugin formats, I think. But not after you release a note. You hear it still going. And you see there's still a bunch of voices playing, even if I'm not playing anything. That kind of stuff is a really, really nice thing with the clap. That you're kind of separating the playing voices and the notes, and you can multiple voices. You can now it's actually up to 64 voices of the same. So you can do a lot of weird stuff with it. And I now, of course, just not even touch the surface on everything. But okay, that's the very simple plugin, and of course you don't see it much at the moment because this is a debug build. But let's compile a release build just to show you terminate. I like to terminate it because it forces Bitwig to reload everything when it gets back up again. So if you now compile as a release build instead, it takes a little bit more time, so you can time it. Let's see, I think it takes about 10 seconds more. A lot of optimization going on probably. And there, 11 seconds, and now we also have it, there it pops up again. So let's just activate and just make a few tracks and drag in the plugin. And now we can just look at the CPU a little bit more, which is interesting. Using it here. And even if you pump up the stacking here, the full release, and so now I think it's 64 voices at the moment, and it's all calculated per sample, everything, even the filter coefficients and everything, envelopes and everything, which is not the best way. Even the modulation, which is coming in every 64 samples, but still I calculate them every sample, so it's not ideal at all. But still, it's I would say it's quite simple, quite efficient in. So this is 64 voices. I could easily have hundreds and hundreds, probably. But again, this is a very primitive synth, so it's not measurable. But that's interesting. So that's the synth itself, and how you can see it actually works. But okay, no, sorry, I want to show you a few other things. One is that the different. Until now we compile as a clap format. This F here means format. We could, for example, say VST3 instead. But of course, then you have to rename the output file, and VST3 wants to have this traditional shared object. We're compiling Linux, by the way. Let's say take debug, it goes faster. So now let's delete this clap so we're not getting confused, and now compile as a VST3 instead. But actually we are not compiling the as a VST3 instead, we are compiling in, adding in the clap as VST3 wrapper on top, and the VST3 entry point. So a VST3 host sees the entry point and loads the VST3 plugin, but the VST3 plugin actually uses the clap part to do its work. So it's just a thin wrapper on top of it. And it, after compilation, takes kind of the same time. We have this shared object file, which is the same as a DLL file on Windows. We have to put this into some specific directory structure in VST3, in build, so it's inside this bundle here. And by doing that, you see that already Bitwig found this as a small tree here. Found it as a VST3 file, VST3 plugin I mean. And then you can just drag down it, and okay, it doesn't like it much. Why doesn't it like it? I have to restart it. Sometimes Bitwig is a bit, what should I call it? I'll clear here too. Oh, sorry. What should I say? Or maybe I did something wrong. Let's see what's happening. Location, bin, and here's the VST3 file. Let's drag it in and see if it works now. Yes, there it is, and there's the VST3 version. There's a lot of things that doesn't work same way in VST3 because of some not the restrictions, but the differences in format, like still synth part, the note expressions, and also this I have this note, the MPE note expression is glide and slide and pressure and stuff working properly, but I haven't connected my keyboard at the moment, so I can't. But it's working both in VST3 and in clap, and also VST2. But the same thing, still resizable GUI. The things that are not working are modulation, mono or poly, voice stacking. Thread pool is not, I don't have a manual thread pool for VST3, I'm just using the clap one, so in VST3 it's all linearly in one thread, so it's not as efficient. No parameter indication or remote controls. A few things like that are different, but the main plugin part itself is kind of the same, and it works in a real way. So it works quite nicely. The parameter and all that kind of stuff, of course. So that VST3 works, VST2 clap works, and let's try some other things. We can also do another interesting thing. We can start it back to clap, but we can compile for Windows instead. This is all But then we have to change the GUI system. We can't really use an X11 GUI in Windows, so we use a bare bones Win32 API GUI with OpenGL. And of course we have to tell the compiler that we are actually compiling as a window binary. So let me see. Yeah, let's time it again, and we want to have debug build because we are lazy. So now let me clean out its VST3 version first. So so it's empty. Yes, it is empty. So now we have this clap file, but this file is, let's look at it. It's a PE executable DLL console for Windows. So it's a Windows DLL file actually. And of course Linux host doesn't like that very much, but I have installed the Windows version of Reaper in Wine, so let's try to run this through Wine. And here we see, okay, new version. Still uses direct sound and everything, so it's I haven't set it up properly, they just make it work. But I still can just grab, I have also set up Reaper to look into this same directory here. So it found the plugin here, and this is a Windows version, bang, and here it is. There is some weird things, as you can see with the Windows yet, there is some, I think there's some flushing going on, because if I resize it, off, it pops up to the correct size. Still resizing and everything works nicely. I can, let's say, have these parameters here, which we, oh, here's some weird stuff. This is obviously Reaper is not, or Wine, I guess. We can add it to this here, so you see them both ways works. Parameter indications, and okay, let me have MIDI input MIDI all. It doesn't find any MIDI inputs. Okay, let's try MIDI, virtual MIDI keyboard. Just view, where is it? Virtual MIDI keyboard. There. Doesn't work. Okay, we have to enable recording. Oh, it is a delay in the direct sound. And I think I can play with keyboard, can't I? So this is a Windows version, it seems to work just as well, but I haven't set up my keyboard stuff in Windows in Wine, because I have to set up jack and all kind of stuff, which is a mess actually. But the Windows works kind of same thing as the Linux version. There's, as you can see, there is some graphical glitches when I update it, because I see it especially in another plugin which has a bunch of layered widgets. If the updating and refreshing is not properly done, it's get messy. But generally, so we can have a Windows version, we can have a Linux version, we can have clap, and we can have VST3 from the same compile, and actually we can compile as a bunch of other formats. I can just print out something from the command line here. This help file from the compile script, you can compile all these formats. Clap, DSSI, exe. Exe means standalone executable. I can compile that one, why not? Let's just by indicating exe, you can compile an executable instead, which you can just run from command line. Oh no, fuck, sorry, the debug build, because I don't be lazy, and then this can be just run from the command line. Because internally we also include a host this time, which uses the plugin itself to do the work and GUI stuff, but the host is kind of opening the window and telling the plugin to get going. And by compiling to an executable, we just indicate starting this host as the first thing instead, so it works quite easily. But it also opens up for the next, not level, but the thing you can do. We can compile still back to a clap file. So traditional, not traditional, but usual clap shared object in clap format. But we can add in something called EXLLEB here, which means executable library. And if I now compile a clap with also this inside, this is I think it's interesting. oh, it's too dark, this. So we compile a clap file now. There. So it's now it's only have this clap file, which is still a shared object file, a shared object for the dynamic and everything. But the interesting thing is that we can just double click it, and it just starts up. So we can run the shared object file directly. We can actually can just rename it. It actually is a shared object file, and we can just run it manually like this, because the extension doesn't really matter. This is a little bit trickery because we do include some, let's go back to clap again, because where are we? File build clap. But as you can see here, we add in some, oh, let me increase this a bit. We add in some interpreted stuff here, which actually do the loading and initialization and running of the internal host. So it's a multi-layered, I don't know, it's probably a hack, kind of, but I know that I think is it libc or glib or something like that, also uses the same method to make itself executable. So, and I've been looking into it, and it looks quite similar, so, but I'm not sure I'm going to publish binaries with this kind of hack, but it's an interesting thing. And of course, even though we can run it manually directly from the command line, let's see, it still works exactly similar as a clap plugin, of course. So in theory, you could distribute one single binary file and have just the symlinks everywhere. One to the standalone executable as a clap as VST3, and also if you want to VST3, LADSPA, LV2, DSSI, etc., etc. Let's see, but just to make me load it so that you can actually see that it's working. And here, this is the same binary as this standalone, that I can run binary here. So it works both as a standalone as a plugin, which is interesting, I think. Funny, more funny than interesting. What more about the compilation stuff? I can do a bunch of weird compilation things, but I'm not perhaps we shouldn't go too much into them at the moment, because this is going to be long in the video. Let me see just if there's any interesting I'll just quickly comment on. The compile script have a few options. Yes, you can compile also as a no GUI, as the GUI type. You could sell no GUI and then get rid of a clap file, let's say, get rid of the exlib thing. You compile a file name and its format is clap, and graphics or GUI type is no GUI. And all of a sudden it took a lot shorter to compile, as you see, and the file is a lot smaller. And the release build is 200K or something. Let's see. As you can see here, it's just 200K, 0.2 megabytes, which is nice. That's the actual code. The rest is GUI stuff. So it's over a megabyte or a million bytes for the GUI part. It also includes a couple of fonts and some bitmaps and stuff. No, not bitmaps, SVGs and stuff. So that takes some space, 500K or something. So that excuses something, but still, I like small anti-bloat things, like tiny small things that help me. I like to compile a clap binary with a bunch of small utility plugins inside of it. So I just have it everything in one place and uses no much CPU and everything. So I just think it's nice to have available. What else can you do? Let's see here. You can compile a GUI also as Wayland, but this part is not very developed. It's very rudimentary. I have to run it with the Western in Linux, because I don't run Wayland usually, which also means that all the hosts are running X11 and not Wayland, so it's a bit weirdo to make Wayland GUI in an X11 setting. but we can do some floating windows and stuff. But anyway, the GUI VLAN part is I can open the not a window, but a so-called top-level surface in and have events going in and out, with the mouse events clicking and that kind of stuff, and being told when to redraw and that, and get this timing stuff going on. But there is no hosts as that supports WLAN in CLAP at the moment. So I can't do much more until some hosts at least have minimally rudimentary support for it. But anyway, that is interesting. Also for other things like embedded Linux with the WLAN hardware GUI stuff, for example. That is something okay, I can't talk too much about it actually, sorry. But anyway, also I have a bunch of debug and sanitize and testing. I included some unit testing stuff in there, and some leak detectors and crash handlers and all that kind of stuff. You can turn on and off. You can add additional stuff. So it's a very simple compile script, and I actually use this for everything. I don't use any make files or CMake or build system or in IDE internal build system or anything. As you can see, I always compile directly from compiled line here via this script, because it takes just a few seconds, and if there's a bug, sorry, I don't mean to curse, sorry. And if there's some bugs, for example, if I did an ugly bug here, and a little bigger, and if I compile, and you see already the princess, I can just control and click on it, and I jumped straight to it, just like an internal IDE build. So there's no need to a build system at all, especially because of how this toolkit is put together. It is actually a multi-leveled thing. At the bottom, you can kind of say that it's a collection of header-only libraries, between 350 and 400 of them actually, all in all. It's getting quite a lot of, not 400 libraries, but 400 files. Let's say 100, 200 things, like Windows, knob, stack, all kinds of separate things in separate libraries. Then collect all those like in a big toolbox of a tool. That's why I call it a toolkit. And then I've used this toolbox kind of to build or set up a plugin framework kind of thing. And then I use that framework to build plugins. I could also use it to build standalone executables, which is this kind of easy. So it's not only plugins, it's just that the main building blocks, or the small building blocks, are mainly focused on or meant for plugin building. But I think, for example, the X11 window is more or less totally standalone, so you can just drag in one single header file, put it in your source code yourself, link in with the OpenGL and X11 libraries, and bang, you have an open X11 window. No need for the rest of the toolkit. So I think it's quite flexible put together. But maybe I should go into the code itself. Yeah, I can very quickly. Let's go again. Let me compile let executable, because it's easier to point to things. So it compiles well. Yes, everything compiles. So this is actually the main file. Weirdly enough, I only use header files again, because of some other reason I can tell about in another video. There is a reasoning behind it. With some bunch of include for what we are actually going to use, and some GUI, some specific stuff. So what we need in a plugin is just this descriptor. It is a clap descriptor, which maybe sounds weird since we are, for example, compiling a VST3 plugin. But the fact is, in the bottom there's always a clap plugin. You're always making a clap plugin. The clap is the internal plugin format. I use everything is based on clap, both the plugin stuff itself And also the GUI API is based entirely on clap. And they have wrappers, and we call it not converters, but interpreters or whatever in between to support all the other things like Windows version, all the plugin formats, all the GUI formats, etc., etc. But at the bottom there is a clap file, and instead of trying to hide away that fact and abstract it away, I decided to just smack in use the clap descriptor directly here. So your plugin needs three things actually. It needs a descriptor, it needs a plugin, in my case a plugin class, but it actually is a bit other thing done lower, but that's the main thing. And finally it needs an entry, a plugin entry point, or some way for the host to get into the binary kind of stuff. And all of them have a kind of, the descriptor is so simple, we don't need to abstract it much. So we need actually just this unique ID for every plugin, so that the host knows about exactly what plugin we are talking about. And we need to tell it a little bit about the features, in this case that it is an instrument or a synthesizer. So you can put it inside its synthesizer or instrument lists inside the host, and then you can drag it onto a track and all that kind of stuff. The plugin is kind of a two-layered approach. We have this basic clap handling, which is C, pure C based. Then we have this so-called SAT_clap plugin, which is the plugin below, which handles all, kind of converts the C to C++ in a way, so that you have a plugin class and everything, and just have virtual functions to override. And then finally we have this plugin thing on top of that clap plugin. So you can code in a more, what should I call it, format or platform agnostic way. There is not, except for this descriptor and a few flags and stuff, the rest is more or less agnostic to everything, or open kind of, or what is it called, or platform agnostic, kind of cross-platform, format cross, blah 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 blah. In theory, but of course not everything is perfect everywhere, so there's still work to do. But that's the idea. The plugin class itself is quite simple. In this case, it just is the voice manager, which handles everything, more or less, about the synthesis part, the voices part, that kind of stuff, on the events and audio processing. And we are initializing a plugin very easily, setting up some extensions, some note ports, in note and audio ports. We prepare some parameters and let the voice manager and the editor. We activate it same way. The rest of stuff is kind of just not just mainly just telling the voice manager what the same kind of thing, because it has to know a few things like the sample rate and that kind of stuff. And then a 3-4 function for supporting some extensions like thread pool here. You just again call right into the voice manager. Voice info is we need, especially for this overlapping notes thing. Remote controls is very basic, as you can see. You just have one page, and we set them up to be 8 specific parameters here. Preset load doesn't do much except call load presets from file and then tell the host that we load it. We loaded it. We handle a bunch of events. Oh, where did I go? Sorry. A bunch of this specific event, not on, off, joke, expression, parameter value, parameter modulation, and some MIDI stuff, and post-processing. And finally, we do audio processing, which again is very simple here. We just tell the voice manager to do the work. And then we scale the buffer with the global gain parameter. So it's very minimal and just for testing. And finally, the editor, just smack it straight into the source code here, like an include file, which is ugly and hacky, but it's just a function, so it's just kind of like taking all of these and grab it and put it in another file and just include it here, very simply, because I want to wrap it up in this no GUI stuff. And finally we have this entry point, which actually is a macro which hides this kind of stuff, but anyway you can just do this. I split the rest is in a few other files, like the very simple ones actually. For widget is not being used much. I've been preparing for some specific knobs here to draw the waveforms and stuff, but I haven't, as you can see, commented out, it's not used. The parameters is a bit ugly, because here's everything related to parameters and index and parameter ID and stuff, and it is a bit error prone and dangerous, but it is what it is. It works, and now I have everything in one place, so I don't mess things up too much. The editor is just setting up all the widgets in the editor. It's just one function, this entire function here. This is the entire file, and it's set up a bunch of widgets and connect them to the correct parameters. So after this connection, you don't have to think much about it. Everything is handled for you. You're just sending the events back and forth in a thread-safe way and in the correct timing, and in that kind of stuff. It goes automatically, everything. So just set them up one by one. This should probably be better if we had a kind of a simplistic editor which could do things like that for us. We could just drag in a knob, for example, and specify some values, and then we could save this header file like this, which you can just include here. That would be an idea. And finally, the last thing is the voice itself, which is very simple again. It's just a single class which we are using as a template argument to the voice manager. So it's kind of included directly in the voice manager, and hence the voice itself. We have multiple other things on top, but this is kind of your functionality. Rudimentary and simple and naive, we just take care of some internal oscillators and filters and stuff, and parameter values. Now what is it? Yes, parameter values, and modulated values, and note expressions. Ah fuck, I'm going to fix it. Sorry, I'm cursing again. I'll try this one. Which lets me find the key. Okay, I turned off because there's some weirdness in between with it too that I haven't really fixed properly. But let me compile to not a clap again. Clap and format clap. Let us see in bind. Get rid of the exe file so that we're not messed up. Now we have this clap file, and let's go into the Bitwig again, and there it found it. We activate it, and let's see if it finds my C board now. Yeah, there it found it. Let's see. Yes, I get notifications. So now what's interesting now, if we now drag it in, we can still, you see, so it supports all the, at the moment I don't only care about the typical MPE expressions, not on and off volume or velocity. So I think it's called lift and press, or hammer or something in the MPE naming, and pressure, but I don't care about it here, and tuning. So this is just it. So that's interesting. You could tune it, and this is automatically. If you have it, just say that you have a clap note port, and then this is automatically handled. Of course, you have to do the math, of course, yourself, but all this. So that's it. And the final thing is this brightness with this y-axis on my keyboard here, but I don't have it connected anything. I just let's see, where is it? I just read it here and save it in the value, but I only use this tuning, I think. Let's see here. Where is it? Here. This tuning. So I just add it to everything else before anything. But you see the note expression works. And this works all. Let me see, I haven't tried it in a while. Let us try it just to be sure. We can compile as a VST3 and see if it's a shared object. Let's see if it actually works in VST3. It's interesting. And now we get rid of this because it's now it's called a shared object, and we have to put it into the VST3. So there it is. So now we're going back, it should show a VST3 file, and let's try if the note expression works properly in VST3. Yes, it does. So I have, luckily I haven't messed up that and forgot about it. What's interesting is called, oh, there's something wrong with my keyboard actually. See? Here it uses. There you see, there it is. Falls out. So it's a dead zone here, and my keyboard is kind of, it's falling apart, so I have to hurry up and finish the note expression before it falls completely apart. Same thing with some of the knobs on my MIDI controller here. For example, some of them doesn't really want to react very much, unfortunately, but why doesn't it? But we'll see. It works. It works both the VST2. I think the VST2 part is not 100% working at the moment. There's some issues. I had to change something, and I didn't really care about bringing it completely back. Same with VST2, LADSPA, LV2, and DSSI. Same with all this. I don't really know if I care enough about them to put a lot of effort into it, but we'll see. If other people ask about it, I might be interested in doing it, but for myself personally, I don't really care much. But anyway, so a lot of stuff works quite nicely already automatically, which is not always nice when I'm making plugins, so you don't have to think much about this boring stuff. But again, the Samal is not that big plugin, but it's more than just this minimal example thing. So I can also just very quickly on the end here now just show you how little is actually needed to create a plugin. Like this minimal noob, no operation. As you can see, 8 lines is all you need to make a complete full-featured clap plugin. But it doesn't do anything, it doesn't do audio processing or event processing or have any GUI, so it's not very much useful, but this is the minimal as you can make it. Next step is this minimal itself, not minimal noob, but minimal, which also has extensions, audio and audio ports and parameters with modulation and audio processing, and then default GUI. And then we can go step by step, more and more up until we reach the templates in instrument templates. Oh, what? Audio and instrument templates. Audio effect, for example, this is a complete gain plugin actually. Oh, what did I do? Plugin actually, it's just one page, so it's easy to start everything with the param. Expand it out a little bit so you see what's going on, and it actually do work and set up a proper editor. So it's easy to, I think, it's easy starting point. Same thing with the instrument, but a little bit more involved because you need this voice functionality. Apart from that, everything is more or less the same, and some events. Note effects is the same thing, but you don't have audio ports, you only have note ports in and out, and in this case you just return through and don't do anything, but because it's a template. So it's a lot of stuff you can kind of work more on if people are interested in it. So it's a lot of, what should I call it, prototyping and or proof of concept code that actually works and works enough that you can actually use it, but to get a really nice pro result, maybe you should do a little bit more work on parts of it. Another interesting file maybe this pure clap file here. This is the minimal pure clap file plugin you can compile, and it doesn't do use anything except clap itself and some standard libs, nothing else, no links and no anything. But it doesn't do anything. It has this entry function, clap entry here. It has the clap factory, and it has just printfs for everything, as you can see in the plugin itself. But it actually compiles and works and loads both in all the hosts I've tested it, and it should be a fully featured clap plugin. It's so interesting to see what's actually needed, and that kind of stuff. It's more interesting things. Let's see how you can combine a bunch of plugins into one. It could be interesting. This is SA Portser, for example. As you can see, this is also a full not a plugin, but a clap file. And as you can see, there's no plugin stuff almost here, except it's just include all the ports plugins here, and just include them one by one, because I've written them in a little bit specific way. And then I do this from two functionality here, one for registering everything and one for creating one, depending on the index. I'm just compiling this one, and you have one. I can show you just to see that it actually works. And let's see, where are we? Let's compile this portser. This portser is this ports file. So if you compile this one as a compile as a, let us compile as exe standalone, because it's much easier to test. But it works, of course, like normal clap plugins, everything. So now we compile this ports thing here, but it's still called build exe, of course, because that's what I wrote here. But the interesting thing now is I double click on it, you see, oh, what kind of plugin is this? It is actually the first one, index 0, in the list of added plugins. Here, actually this one, which is automatic with a generic default GUI if you don't specify any. But you could start any one of the other ones by, let's open this in a F4. Yeah. You can just run, what is it, build exe, I think it's /l, I think, or and there's a list of all the plugins included in the binary. And then you can start one of them, let's say whole reverb number 5. So then we start number 5, and then it's the whole reverb. Of course, in a host, when you compile a clap plugin, this list here will be inside the host instead, of course. Okay, let me do that too. Because it's so quickly to compile and everything. So now we compile as a clap everything, and let's get rid of this console here. So now we have this exe. We don't need that anymore. The clap file, and now if you go into, you see a bunch of clap plugins all of a sudden. You see this is found this build.clap, bang, and inside of it you see here it's 18 plugins. Here's the same 18, these ones. Let's list it up, and you can just drag whatever you want. Use them as plugins. No GUI. Oh, here's a GUI. And everything. As each of them is completely separate, so you can have as many as you want, of course. Or does it want to? What about the event horizon? There's some. I need to restart. Okay. Kill. No. Let me. Oh, there's some state. I know exactly what's going on. I know what's going on. So we have to restart it. This is because of the, I forget it. I know what's going on. We'll fix it later. But let's try again from scratch. Always a nice idea when working with computers. Event horizon, for example, we drag this one in here, and we have it here. Then we let this try this free word, and it pops up here. So we can use all of them separately, of course, even if it's just one file. So that's nice. So it works, multiple plugins, and the same thing for VSec3 and VSec. not VC2. VC2 has the shell functionality, shell plugin functionality in VC2 is a bit shaky. It's harder and harder to find documentation stuff. And I made it work in Bitwig, so I can compile a multi-plugin VC2 binary kind of stuff. But Reaper kind of gets into this internal loop, trying to enumerate all the shell plugins. So there's something, I think I know what's wrong, but I haven't really cared much about VC2 lately. But that could be for both for LUDSPA, LV2, and the same thing with DSSI. There's no point in DSSI anymore. But the LUDSPA, it's nice because it's so minimal and so little resource hungry. So I like the format just because of its minimalism. Not like, but kind of like. But LV2 should also, in theory, support multiple plugins, but there is this turtle TTL file, so it's I won't talk more about it. So I plan to actually get rid of everything except for standalone, clap, VC3. I don't see much, and for Windows and Linux probably. So that's what I kind of think I'm going to focus on. But anyway, you see it's quite flexible and stuff. Documentation is bad, I know, but I have tried to just so that at least you have something to look at. It's in the doc. I have produced in Doxygen file here, which I just I call it now and then. Let's with this. And let it just go on in the background here, and then it fills out these directories here, and then you can start this. It's not that there is almost no comments or Doxygen comments in the file, so it's not a good thing. What should I say? Not a good documentation. As you can see, there's nothing here, but you can already look at, for example, all the classes, and here for me myself I also see a few things I have to do. All these code prefixes are from the older versions of the library, and it's currently inside some backup directories, but Doxygen finds them, so it just implements. But I will convert all of them, both code and MIP, which is from the MITP2 toolkit, over to this SAT format here. And here you see all these header files, actually header files libraries. Everything is, you can think of every single one of these as a single header only library in a way. It's kind of interesting. Some plugins, for example the plugin part here, is quite interesting to look at the connection between them. For example, it looks like a mess, which is actually probably is, or it's getting big. But maybe I will just funny. I think it's just nice to get a kind of overview, but not really. It's more mess than. Yeah. Okay. And by the way, before I forget, here's the link to the toolkit: github.com/shay/sa_toolkit. Just in case you want to check it out. What more? Is there anything else that could be into? I could of course go through all the plugins that's included. There's 30 maybe. There's all these ports. These are ported from all over the place. There is some templates to simplify startup, and some all these SA things here are some plugins I've started myself. Some interesting, some not interesting. And a bunch of examples and tests. So there's quite a lot of things to look at already. Another, maybe if you want the GUI part, I have another interesting thing, I think, called the demo. It's not proper demo, that was the idea when I started it. Like a lot of them, but it's kind of a GUI demo. So I think could be interesting to look into just a little bit. It shows a bunch of the widget types and features and what you can do with the GUI part. All these are widgets in exactly the same way as the knobs and everything. You can just create them and in your editor, and bang, everything is connected. A few nice things like opening and closable panels. We have tabs with different widgets in different tabs. This is our so-called panels, which is the backgrounds for everything else. You can drag values. We have sliders with snapping and quantizing. Same thing with knobs. Knobs with snapping, or shift to not snap, or control to go slowly. And it's quantized. And we have some curved things, buttons. We have a selector, which is actually, this is actually a pop-up menu, but I just stuck it on the bottom of the line here to call it a drop-down box or whatever. I just call it a selector. And you have text editor, which is very, 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 very primitive. For example, hosts usually like to steal the spacebar. But so shift space works, but anyway, this is very, very rudimentary, only meant for testing and making it possible to edit, for example, save preset names, for example. The text is wrong here. It should be scrollable, which it isn't. You have some grid stuff, which actually is the basis for all of these button rows. There's also a vertical one, but I haven't added it. Keyboard to indicate either playing or switching on off chords or whatever, and some other different versions of sliders, so you can edit in different ways. This is more meant as like kind of a zoomable thing, and maybe I could put it at the bottom here to make this entire thing here zoomable. So I could, in case I move it, oh, where is it? So I can scroll over to it. And this is a sequence, a kind of timeline kind of thing, by the way. So it's again very simple, very initial starting points, but it's a starting point. It's editable. It's different ways, all kinds of stuff. So you can already make it not massively big, but working GUIs with the toolkit, I think. Everything is smoothly resizable, and there's some aspect ratio and some scaling. There's some different things you can set up depending on if you want scaling, if you want the aspect ratio thing, if you want whatever. There's a bunch of things. And we can support SVG files and PNG files, both zoomable, of course. So we could have, for example, this typical, what is it called? Button, the whole long row of buttons, and the button strip or knob strips, for example, instead of one of these. I have one already, but I haven't included because I like vector based. And finally, we also have these movable widgets. So you can put in everywhere, and it could be aligned to something, it could be layout, it could be stretched, it could be whatever, but generic is you can move them around and you could resize them. Oh, but as you can see, there's some issues with it at the moment, because I haven't really found much use for it, except I will probably use it as a kind of a pop-up box to show info, more like, for example, license info and that kind of stuff. I could have made the end, and there's a bunch of settings in all the widgets, everything, but I haven't really shown it. This is based to see it. Does it work? Yes, no, and if I do something, will it mess up other things? So that's the main reasoning for all this testing here. And also to take OpenGL stuff. There's a bunch of other things I could maybe go into, but let's keep that for another video maybe, or if people are actually wondering about things instead. So if there's anything you wonder about, or don't understand, or have suggestions, have complaints, if you have whatever, just get in touch either by comments here or in the GitHub repository about the discussions and the issues. You just fill them up with the noise, it doesn't matter. If I hear from people, I actually will look into it, and so don't be shy. So that's an introduction, a crap one, but it is one, so okay, that's it. Let me know if there's anything.